Hi everyone, welcome to GoClasses. So in this lecture, we will do some practice of ordered indexes. We have already seen the different type of ordered indexes like primary index, clustering index, and secondary index. In the secondary index, we have two type of index. One is secondary index on key attribute, another is secondary index on non-key attribute. Okay. So in this lecture, we will do some practice of ordered indexes. All the concepts that we have seen, every concept, everything that we have seen, every definition, every concept. Okay, we will do some practice. So we are going to solve 32 questions. Okay, and these 32 questions cover everything. Okay, in these 32 questions, everything, every concept, every type of variation, every question is covered. Now let's start. So tell me the answer for this question. See, we have already seen all the concepts. Now you just have to tell me the answers. Read the question and tell me the answer. Consider a relation R which is A, B, C, D. This is a relation. Assume A is the key. This is a candidate key. Now, file R is stored in 100 blocks. Okay, total 100 blocks are there. So this file we store in 100 blocks. Now, this is a query that we write. Select star from R where A equal to 10. So tell me, this query is searching based on what? Tell me. This query, this will search the relation R based on what? Based on attribute A, right? So in the relation R, we want to find where A is 10. Those results, those records, we want to find where A is equal to 10, correct? So you can notice that we are searching based on A. Okay, in the relation R, there are 100 blocks. The relation R total has 100 blocks. We are searching the relation R based on A. So search, I can say basically search is based on A. You are searching based on attribute A. Now, what is the next? There is no index. We don't have any index on relation R. So this relation R has no index. Now, file R uses heap organization. What is that? Tell me what is heap organization? Heap organization simply means that completely unordered organization. Yes or no? Completely random organization. Like randomly you are inserting the data. You can insert the data at the end of the file. Anywhere you can insert. Okay. Wherever you get the space, there you can insert the data. So heap organization simply means that every field is unordered. It simply means that every field is unordered. Every field is unsorted. No field is sorted. Every field is unordered. Now, what is the number of disk block access needed? Tell me. What will be the number of disk block access needed when you perform this query? Okay, when you find the result. And remember, A is a key. So how many records are there with A equal to 10? Remember, A is a key. A is a key. So how many records are there with A equal to 10? So there is only one record, right? Yes or no? Because A is a key. It simply means that there is only, I can say there is at most one record. Maybe there is no record. Maybe there is no record, but I can say that there is at most one record. Okay, because you can see A is a key. A is a candidate key. So this query will give you at most one record. This query will output at most one record will be in the output. Okay, now, so what is the number of disk block access that you need? So the answer is very simple. Because this is a heap organization, so you cannot apply the binary search. In this situation, you can notice the maximum, or I can say worst case. In the worst case, you need to access all the 100 blocks. In the worst case, all the 100 blocks you need to access. And in the average, what is the average? On average, I can say that B by 2. On average, I can say 50 blocks you need to access. So if the question is asking for the average, then answer will be 50. Okay. If the question will ask you about the average, so average number of blocks that we need to access is 50 and maximum number of blocks that we need to access is 100. And on average, I can say B by 2, average is B by 2, that is 50. So the answer for this question is 50. So did you get this answer correct? Tell me, was your answer 50? On average, your answer should be 50. On worst case, your answer should be 100. Okay. Now let's see the question number 2. Tell me the answer for this question number 2. Again, consider a relation R. Again, A is a key. Again, you have 100 blocks. Now, everything is same. But now your file is sorted by order, sorted by A. This is the difference. Okay. Your file is sorted by A. Now, in the question, they will ask you. They will basically ask you about the average. Okay. In the question, they will ask you for the average. Don't worry. In the question, they will mention that average number of disk access. So average number of disk access needed is 50. Okay, don't worry about it. They will mention it. Now you tell me about this question. What is the difference? Everything else is same. Your file needs 100 blocks and A is the key and this is the query. So this query, basically I can say there is at most one record with equal to 10. So you can easily see that there is at most one record with A equal to 10. Now you tell me, now your file is ordered by A. Your file is sequential. You can notice this file. You are using the sequential organization. This is a sequential file. This is a sequential, or I can say ordered file and ordered by A. And index is, you can notice there is no index. Remember, there is no index. So we don't have any index. In this situation, what you can do? You are searching based on A. Your search is also based on A. Right? So you are searching based on A, and you can notice that your file is sorted based on A. File is sorted based on A, searching is based on A. So then you can apply the binary search, right? So in this situation, what you can do? You can very easily do the binary search. Okay, so if when you do the binary search, then the answer is going to be log of 100. In worst case, again, this is the worst case. This is not the best case, right? Okay, so this is the worst case. So the answer will be what? In this situation, you can notice the answer will be 7 disk blocks. 7 blocks. Remember, this is the worst case. Okay, so in worst case, you need 7 blocks to access. In the worst case. Yes, in this situation, the worst case, they will ask. Don't worry, they will ask you the question, Mavit. They will mention what they want to ask. They will mention that what is the worst case, like in worst case, how many blocks we need to access. In different questions, different things they can ask. So depending on the question, you can answer. In this question, they will ask you, what is the worst case number of disk block access that you need? So you can see that 7 blocks you need to access in worst case. Is this question clear to everyone? Because there is no index. We don't have any index. So your file is sequential file. Your file is ordered. So we can apply the binary search. And that is the reason for 7 block access. That is the worst case. This is your question number 2. What is question number 3? Tell me the answer for this. The question is same. A is the key. Everything else is same. There is no index. But your file is ordered by B. Now your file is sequential, but your file is ordered by B. Can you take the benefit now? Now, can you take the advantage? In this situation, can you take any advantage? Because remember, you are searching based on A. Remember, you are searching on A. You are searching based on A. Correct. We are searching based on A. So here you can say you are searching based on A, but your file is sequential by B. Your file is sequential. Your file is ordered by B. So again, we cannot use the binary search, right? Okay, very simple. So we cannot, this is the important point, that in this question, we cannot use the binary search. So we cannot get the benefit of use binary search. We cannot get this benefit. So if you cannot get this benefit, then again, the answer will be same, that on average, you need to access 50. On worst case, on maximum, on worst case, 100 blocks you need to access. On average case, 50 blocks you need to access. In this question, actually, they will ask you about the average. Okay, so whatever they ask, they can ask you a worst. If they ask you worst, then answer will be 100. If they ask you average, answer will be 50. Whatever they ask you, you understand the concept. Your focus should be on understanding the concept. In the GATE exam, they can ask you any question, you can answer it. Okay, so 3 questions are done. Did you correct these 3 questions? Tell me. All these 3 questions, did you correct? Okay, let's see this. Let's see the question number 4. Tell me this. What is the answer for this question? Again, consider a relation R. Assume A, B are the 2 keys. So A is a candidate key, B is a candidate key. Now, file R is ordered by A. You are creating index on A. Then that index will be called what? You are creating index on A. So you can notice file is ordered by A. Your file R, that is ordered by A, and your A is key, and you are creating index on A. So this type of index we call primary index. This type of index we call primary index because this is created on A. This is primary index, right? Okay, so this is a primary index, and you can notice because this A, this is basically the ordering key field. This is the ordering field because your file is ordered by A, and this is key also. This is candidate key also. So this is ordering key field of R, of the data file R. Okay, so on this field, if you create the index, then that index will be called primary index. So your answer is going to be primary index. This is going to be your answer. Tell me the answer for this question. Question number 5. Your file is ordered by A. Okay, your file is sequentially ordered by A, comma B are the keys, but you are creating index on B. File is sorted by A, but you are creating index on B. So it simply means this is a secondary index, right? This is the secondary index on key. So you cannot, this is a secondary index which is on key. Correct? Yes or no? Because remember, your file is sorted by A automatically. What means your file is ordered unordered. In your file R, you can notice in file R, you can easily see that B is unordered, right? B is unordered in the file R. This B is unordered. Now on this B, if you create the index, on this B, if you create index on B, then that index will be called what? That index we will call secondary index. Okay, we will call it secondary index. Yes or no? Is this clear to everyone? Tell me. So you can notice if you order by A, then automatically your file will be unordered on B, comma C, comma D. If you order this, if you order this, if you order this or ordered this, then automatically they will become unordered. Then they will become unordered. So here, if you create index on B, that will be called secondary index on key. Yes or no? So this is your question number 5. You calculate your marks. So far, how many marks you got? You calculate your marks, remember. Okay, just calculate your marks. Tell me the answer for this question. Tell me this. Read the question carefully and tell me the answer. You can pause the video. In the live class, you cannot pause the video, but if you are watching the recorded lecture, then you can pause the video. Okay, consider the relation R. Again, A, comma B are the keys. File is sorted by A, index on C. See all the variations I am covering. I will cover each and every variation. Whatever variation come to your mind, I will cover it. So you can notice A, comma B are the keys. And file is sorted by A, automatically what means that this is a secondary index on non-key. So this is a secondary index on non-key, right? This is a secondary index. That is the point. Because once you sort your file, okay, this is sorted in your file, this or this is sorted. So automatically these will become unsorted, right? Automatically these fields will become unsorted. So you can see that if you create file on, if you create index on C, that index will be called secondary index. Okay, this is your question number 6. Tell me the answer for this question. Now your file is ordered by C. And remember A, comma B are the keys. A, comma B are the keys. File is ordered by C and your index is also on C. This index will be called what? So you can notice your file, you are ordering this. This field is sorted. This field, okay, sorted. This field in your data file, this is your data file. So in the data file, this field is sorted. Okay, in the data file, this field is sorted. Now you are creating index on this also. Then that will be called what? Okay, so you can easily see that this is C, this is a ordering field, but this is not a ordering key field, right? Agree or not? This is the ordering field, but this is not the ordering key field. This is a ordering field, but this is not a key. So if you create index on ordering field, on the ordering field, if you create the index, that will be called clustering index. This index is called clustering index. On short, you can write it CI. So this will be called clustering index because this is a ordering non-key field. Very good. Okay, so this is a ordering non-key field. On the ordering non-key field, if you create the index, that index will be called clustering index. So this is your question number 7. Let's see the question number 8. Every variation we will cover. Okay, your file is ordered by the C. So this C is ordering non-key field. Ordering non-key field. Okay, so you cannot, this means ordering and this means non-key field. So this is the ordering non-key field. Now if you create index on A, then that will be secondary index on key. Right, secondary index on key. Are your concepts becoming clear? Tell me, are your concepts becoming clear? Because you can notice this C, okay, this field is sorted. If this field is sorted, then automatically this will become unsorted. This field will become unordered. So if you create index on unordered field, then that will be called secondary index. And because it is a key, this A is a key. So you can call it a secondary index on key. This is the name that you can give. Tell me the answer for this question. Question number 9. Your file is ordered by C and your index is on B, index on D. So because you are ordered by C, so automatically this becomes unordered. This becomes unordering field. Okay, so this is an unordering non-key field. Unordered non-key field. So this is an unordered non-key field. So this index on this D, that will be called secondary index on non-key. Because this D is non-key, so this index will be called secondary index on non-key. So this is question number 9. Tell me the question number 10. Now, your file is a heap file. Your file is using the heap organization, means no field is ordered. There is no field which is ordered. So your file is using the heap organization. Now you tell me, if your file is using heap organization, then there is no field which is ordered, right? Because you are using the heap organization. So every index that you create will be a secondary index. So this will be a secondary index on key, because this so this will be a secondary index on key. Because remember, no field is ordered. In your file, every field is unordered. So all these fields, they are unordered. Because you are using the heap organization. In the heap organization, what we do? We can insert anywhere. Yes or no? Any record, any tuple, we can insert anywhere. Okay, so that is the idea. Now tell me about this question number 11. What will be the answer? Your file is heap file. Your index is on D. That is your SI on non-key. Okay, so this will be your answer. SI on non-key, right? So far, total 11 questions are done. Tell me your marks. How many marks you got so far? Some of you 10, some of you 11. Very good. See, if you are getting 10 or 11, that is very good, because it simply means that you understood the concepts that we have seen. We have seen every concept. Okay, we have done questions, we have done every concept, standard questions we have done. Okay, from the Navate book, from the other books. So the standard questions and everything we have seen. If you are getting 10 or 11 marks so far, then that is very good, that you understood the concepts. Okay, now you can apply. Now you can apply the concepts. Whatever you understood, now you can apply. So tell me the answer for this question number 12. Your relation R, it has two keys. A, B are the two keys. Your relation R is sequentially ordered by A. Okay. Now the question is asking, how many indexes can we create using single attribute search key? Okay. How many indexes we can create on single attribute? On single attribute, how many indexes we can create simultaneously, and mention their types. See, this is an interesting question. Mention their types. So how many indexes you can create on single attribute? Are 4 indexes you can create, right? Yes or no? On every attribute you can create 1 index. So 4 index you can create. Correct or not? Yes or no? 4 indexes you can create. On every attribute you can create 1 index. There is no problem. Okay, their type will be different. Yes or no? Their type will be different. See, the question is very well framed question. In this question, the information is given using the single attribute search key. On single attribute search key, how many indexes you can create? So here you can notice, on single attribute, you can create index on A, index on B, index on C, or index on D. Correct? Yes or no? Now, so if you create index on A, and in this question, what he's saying? He is saying that your file, your data file, this is the information that is given to you, that your data file R, this is sorted. Okay, this is sorted on key. This is sorted on key A. Okay, this information is already given to you, that your data file is ordered by A. Now, if you can create index on A, right? That will be called what? If you create index on A, that will be called primary index. You can call it primary index. The same, if you create index on B, now everything will be secondary index. Now everything is going to be secondary index, right? On other fields, whatever on other fields, every index will be secondary index. So this will be primary index. This will be secondary index on key. This will be secondary index on non-key. Yes or no? Tell me, in this question, all your concepts are covered or not? See, in this question, so you can easily see that you're sequentially ordered by A. Your file is sequentially ordered by A. So because your file is sequentially ordered by A and A is a key, so you can create 1 index on A. That will be called primary index. Okay, this index will be called primary index. The remaining indexes will be secondary indexes. Tell me the answer for this question. Now your file is sequentially ordered by C. Okay, your file that is sequentially ordered by C. Now how many indexes you can create? How many? So the answer will be, again, you can create 4 indexes. On every attribute, you can create 4 index. Now, because your file are ordered by known key, ordered by known key C. So in this situation, you can create index on A. You can create index on A. You can create index on B. You can create index on C. You can create index on D. So these indexes you can create. Okay. Here, the index on C, if you create, that will be called clustering index, right? So that is going to be called clustering index because your file is ordered by C. Your file that is ordered by known key C. So that will be called clustering index. The remaining will be secondary indexes. All the remaining, they are going to be secondary indexes. This will be secondary index on key. This will be secondary index on key. And this will be secondary index on known key. So you can create all these indexes simultaneously. At the same time, 4 indexes you can create. And this will be their types. Question number 14. You calculate your marks and tell me, so far in the 13 questions, how many marks? Tell me. Okay, so calculate your marks. Now, make sure that now you get everything correct. Okay, make sure. Now, let's see this. Question number 14. What is the answer? Your file is a heap file. So, no field is ordered. Okay, this is the meaning of the heap organization. And A, B are the keys. How many indexes can be created? Yes. How many indexes can be created? The answer will be 4. And you can notice because your file is heap file, so all of them will be secondary indexes. 2 of them will be on A, on B. On A, on B, if you create. Okay, so the index on A, the index on B, that will be called SI on key. And the remaining 2 will be SI on the remaining. The remaining will be called SI on known key. Okay, so total 4 indexes you can create. Total 4 index you can create, but you can notice now every index will be second index because no field is ordered. There is no field which is ordered. Okay. Question number 15. Tell me the answer. Your file is a heap file. No field is ordered. Okay. I think this is the same question. Wait a second. Oh, same question. Okay. So this is the same question. Okay. Forget about it. This is the same. Let's see question number 16. Marks to all. Yes. For question number 15, marks to all. No. If your question number 14 was wrong, then you can minus marks for 2 questions. Okay. So that you can do. Okay. Anyway. So tell me the answer for this question. Consider relation R. We create now. Okay. Now from the index point of view. See, so far all the questions were from the file point of view, right? Yes or no? In all the questions, we have the data about the file. I was giving you information about the file. Agree or not? So far, the questions were from file point of view. Now the questions will be from index point of view. I will give you the information of index. Then you tell me what type of index this is. Okay. So all the variations I am trying to cover, each and every variation that is possible, I will cover. Okay, definitely. Now let's see. So consider relation R. Let's assume we create an index I on R. Okay. We have an index I on R. Now the question is saying that the physical order, the order of search key in I, okay, the order of search key in I is the same or almost same as order of R, then what can you say about the index? What this I can be? So this I can be either primary index or it can be clustering index, right? Yes or no? So you can call it either it can be primary index or it can be clustering index, because you can notice very simple idea that, okay, tell me your primary index or your clustering index, only these 2 indexes, they have the same order. Okay, they have the same order. The search key will be in the same order as that is in the relation R. Agree or not? Yes or no? Because your data file is sorted. If you are creating primary index or if you are creating second clustering index on attribute A, then what it automatically means? Tell me. If you are creating primary index or clustering index on A, then what it automatically means? It automatically means that A is sorted here. It automatically means that this A is sorted, right? Okay, it automatically, this means this A is sorted, correct? So this A is sorted, and you can notice this index is always sorted, right? Yes or no? This index is always sorted. So this index is always sorted. So it will happen that, and this index is on A, and this is the pointer. Okay, this is the block pointer. So here you can note this order and this order, they will be same. Yes or no? Agree or not? They will be same. Yes or no? So is this crystal clear? Tell me, is this question crystal clear? That if you have a relation R, you are creating an index, and that index, the search key in that index has the same or almost same order as I, then I can say that index, either that is primary index or clustering index. Yes or no? Okay, is this clear? So with this information we can only say this. With this much information we can only say this. Mayuk, is this clear? In this question, with this information only we can say this. Okay, more we cannot say. Of course, more information should be given, that the search key is the key. If they say that search key is key in R, then we can say, okay, primary index. If they say search key is known key in R, then that will be clustering index. Okay, is this clear, Mayuk? So with this information we can only say this much. See, in the option, basically in the option, if they give clustering index, that will be the answer. In the option they give primary index, that will be the answer. They will not give both of them. Okay, so or more information will be given. Okay, if more information is given, then you can select. Like if they tell you this search key in the data file is key, search key of this index in data file is candidate key, then you can say this index is primary index. Okay, so like that. Now tell me about this question. Question number 17. Consider a relation R. Again, your relation is R. You are creating index. The order of search key in I is different from the order of R. It simply means this is a secondary index, right? So this simply means it is a secondary index. More information we cannot give. Agree or not? Whether it is on key, whether it is on non-key, more information we cannot give. But I can say that this is secondary index. Because in the secondary index, what happens? See. Okay, just think about it and tell me. If you are creating a secondary index on attribute B, what it means? It simply means that in data file, this is unordered, right? Okay, it simply means that in data file, what will happen? In data file, this B is unordered. Agree or not? Yes or no? This B is unordered, but where? Yes or no? This B is unordered, but where this is unordered? Yes or no? You should understand like that. See, in which file this is unordered. So if you are creating secondary index on B, then B is unordered, but in the data file, this is unordered. And what will happen in the index? In the second index, of course, it will be ordered. Every index is ordered. So you can notice this B will be unordered here. In the data file, what will happen? In the data file, what is going to happen? In the data file, this B will be unordered. Like this B will be something like this. Maybe, okay, 20, 60, then 10, then 80, and then 5. So this B is unordered in the data file, right? Okay, so this B, you can clearly see this B is unordered in the data file. Okay, unordered in data file. So this B is unordered in data file. Now, okay, in the index, what will happen? In the index, you have a B and there is a block pointer. In the index, this will be sorted. Okay, so 5, 10, 20, 60, 80. So you can clearly see that this order and this order, they are different, right? Okay, so they are different. This order and this order, they are different. So your answer is what? Your answer is, you can say your index is secondary index. Question number 17. You keep calculating your marks. Okay, now we are going to the gate questions. Now we will see all the gate questions, each and every gate question. But tell me how many marks you got so far? Okay, forget about marks. You tell me, can you say that you understand this concept? Like, can you say that you can explain this concept in any interview, in gate exam, in any exam? Okay, in a very crystal clear manner. Whatever question they give, the question is from the data file point of view, from the index point of view, the question is anything. Okay, they give you any variation. Can you crystal clearly explain the concept. Okay, yes or no? Correct. You will never make vague statements. Like what happens in the I see many students, they create vague statements. When your understanding is not good, then what you do? Then you will create some vague statements. Yes or no? It happens when our understanding is not good, then we will give some vague argument. Okay, some unclear argument we will give. But when we have crystal clear understanding, then we can give any variation, anything they ask. Okay, we can explain in a very nice way. Okay, yes, Mavit is saying that explain them such that they join Go classes. Yes, so you should explain them in such a way they will ask you, bhai kahan se pada? Okay, then you can say Go classes. Okay, so Go classes if you want to study in the best way. Okay, now let's see this question. So this is a GATE Computer Science 2008 question. You tell me the answer for this question. The same question has come in the ISRO 2016. Okay, now this question is a cakewalk for you. Yes or no? Correct. This is a cakewalk for you. Very simple. So a clustering index is defined on fields which are a clustering index. It is defined on fields which are known, key, and ordering. So the answer will be option A. Okay, known, key, and ordering. So very simple. Now let's see the question number 19. Okay, see this GATE Computer Science 2013 question. Question number 15. Now tell me, an index is clustered. When can you say an index is clustered? In which situation you can say an index is clustered? So the index is clustered. It is on the set of fields that form candidate key, not necessary. It is on set of fields that form primary key, not necessary, right? Yes or no? Agree or not? Okay, not necessary, not necessary. Okay, so you can clearly see not necessary, both of them. So these are option A, option B. These are not correct. Now you can notice an index is clustered. When can you say your index is clustered? Your index is clustered if the data records of the file are organized in the same order as the data entries of the index, right? That is correct. Yes or no? In the clustering index, the order of the file is same as the order of the index. So this is a very nice statement. See, in this question, the statement is given very nicely that they are saying the data records in the file are in the same order as the data entries in the index. Okay, so for this question, answer is going to be option C. Okay, and what this type of index, what we call this type of index is called secondary index. Okay, for the option D, I can say your index will be secondary index. And what about this? What about this? Either your index will be primary index or your index will be secondary index. In this situation, either you will have primary index or you will have secondary index. In this situation, that include a primary key. Okay, the same thing here also. The same thing here also, primary index or secondary index. Okay, now let's see. So is this clear? So for this question, the answer will be option C. So all these questions, they are cakewalk for you. Now let's see this question. This is a GATE Computer Science 2015 question. Tell me the answer for this question. Tell me the answer for this question. No, here clustering index is not. See, on these two, option A, option B, clustering index is not possible. Mavit. Okay. For index, for option A, option B, clustering index is not possible. Okay, tell me the answer for this GATE CSE 2015 question. What is that? Now the question is saying, read the question carefully. A file is organized such that the ordering of data records is the same or close to the ordering of data entries in some index. So that index is called what? Okay, so that is clustered index. Your answer. Okay, so that index is a clustered index. Yes or no? And this is the definition of clustered index. This is not the definition of sparse index. Yes or no? This is not the definition of sparse index. This is the definition of clustered index. A sparse index you can create, like a sparse index is a property. Yes or no? See, sparse index is a property. Yes or no? Is this clear? Remember, sparse or dense, that is a property, that is an implementation. Sparse is an implementation, dense is an implementation. Okay. Sometimes you can create both the type of implementation. You can create dense and sparse, both type of implementation you can do. Sometimes you can only create sparse implementation. Actually, no, it is never. See, it is never true that you can only create sparse implementation. Yes or no? You can always create dense implementation. whatever data you take, you can always create dense implementation. Yes or no? Are you getting my point? Whatever data you take, you can always create dense implementation. So this sparse and dense, that is different. This definition is of the clustered index, that your data file order, the order in the data file is same as the order of data entries in the index. So that index will be called what? That will be clustered index. Yes or no? So for this question, the answer will be option C. Is this clear? And unclustered means basically secondary index. This is another word people use for second index, that this is unclustered. Okay, so many people, they use second index instead of second index, they use this word unclustered. Okay, sir, primary key also included in option. Where is primary key? Mavit, what is the doubt? Is this question clear? Mavit, tell me. More variations I will take. Tell me. Is this question clear? Question will be created. The question maker is creating the question, then option also will be changed. If you change the question, then option also might be changed. Okay. So is this question clear? Is this particular question clear? If you are changing the question, then of course you should change the option also. Okay. Yes, in the options, if you do not see, from this information, you can say that index is either CIE or PI. From this information, you can say this. From this information, you can say that either your index is CIE or your index is PI. Yes or no, Priya? The information that is given in the question, from that information, you can only say that your index is CIE or PI. So from the options, option C is the best. Yes or no? Is this clear? Yes, that is what I'm saying. In the last question, we have done this. So this index, okay, this index, from this information, what this information is given, from this information, we can say that the index is either CI or the index is PI. Okay, but from the options, you can see the best option is option C. Yes or no? Because the clustered index will have the same order as the data, as the record. Similarly, the primary index will have the same order as your data file. So your primary index as well as your clustering index, they will have the same order of entries as your data records in the file, in the data file. Is this clear? Let me know. Okay. Don't worry, like the question will be given to you. Whatever question is given to you, according to that you can solve. Okay. Now, so far we have seen total 20 questions. Now we will see some more questions. Okay. Now Mavit is saying that, sir, can we choose sparse as both CI and PI is implemented using sparse? But that is not the definition of sparse. See, the statement that is given, that is not the definition of sparse. Because your clustering index has this property, so you are implementing this as a sparse. Please understand. See, this is the definition of clustering index. Now the clustering index you can implement either as sparse or dense, but we implement as a sparse. Are you getting my point? See, the definition that is given in the question, the statement that is given in the question, that is the definition of clustering index. Now for the clustering index, we can decide, okay, I want dense index or I want sparse index. By default, we create a sparse index. Similarly, for the primary index, I told you that we can create dense index also, we can create sparse index also, but by default we create sparse index. For the secondary index, we create dense index. Okay, so this is dense or sparse, that is a decision that we can make according to the index. But the definition that is given to you, this is the definition of clustering index. What is the definition of sparse index? See, in the same question, if I give you that we are creating index in which only for some data records we are creating the index entry, then your answer will be sparse. Are you getting my point? In the same question, when your answer will be sparse, tell me. See, when your answer will be sparse, in the same question, your answer will be sparse in this situation. If I say that you have an index, okay, if you have an index entry for some records of data file, okay, then this index will be sparse. Then your answer will be sparse. This is the definition of sparse index. Priya, Yuvraj, Mavit, please tell me any other doubt. I'm waiting. Okay, please tell me. Any other doubt? In the previous question, the answer was CI or PI. In this question, are you asking the doubt? Last gate question. Yes. So in the the index is clustered if. So you can notice it is on the set of fields that form a candidate key. Then see, if you are creating an index on the candidate key, if you are creating an index on the candidate key, then that will be SI or PI. Your index will be either SI or your index will be PI, depending on whether that is ordered or not. Okay, because if you want PI, then definitely you need sorted file. You need ordered file. Any other doubt? Priya, Mavit, Priya, Yuvraj, Nikhil, any other doubt? Okay, now let's see this. So you can notice, as I told you, do you remember in the beginning of the indexing chapter, I told you that many students, they think they understand, but they lack the crystal clarity in the indexing chapter. This crystal clarity is not there. Okay, so now we will solve 12 more questions. So far we have done 20 questions, but now we are going to solve 12 more questions. Okay, so in the crystal clear way, you should understand everything. I think you have understood. Okay, now the remaining 12 questions we will see, and those 12 questions also you answer. So basically this video, this practice session, I'm going to upload on the YouTube channel, on the GoClasses YouTube channel. So tell me in the comments. Okay, do you have the crystal clarity about all type of indexes? Okay, do you have that crystal clarity? You tell me in the comments. Okay, now let's see this question number 21. Tell me the answer for this. How many clustered indexes can we create on a file? And the answer is at most one. The answer is at most one you can create. Okay, in which situation you will say exactly one? In which situation you will say exactly one? When your file is ordered based on known key. Okay, sequential plus known key, right? Yes or no? Your file is sequential based on known key. Your file must be ordered based on known key. Then you can say that we can create clustered index. But at most one clustered index you can create. You cannot create more than one clustered index. What is the answer for this question number 22? Would you always be able to create at least one clustered index? And this we have already seen, the answer is no. Because if your file is heap file, then you cannot create. Also, if your file is sorted by key, yes or no? See, if your file is heap file, then we cannot create. If your file is heap file, or I can say it is using the heap organization, okay, or file is sorted, or file is sequential by key. Okay, then in these situations, okay, in this situation we cannot create. In these two situations, I cannot create. We cannot create. No clustering index possible. The clustering index is not possible in these two situations. Okay, in these two situations, the clustering index is not possible. We cannot create clustering index in these two situations. That is not possible. Let's see the question number 23. You tell me the answer for this. A clustered index is the one in which the search key order, okay, in which the order of entries in the index corresponds to order of data records themselves in the underlying file. Okay, yes, this is correct, right? In the clustered index, the order of index entries, that is the same as the order of data file. Okay, so this statement is true, because we already know that in the clustered index, the order of the index, that is the same as the order of data file. Okay, yes, that is what I'm saying. See, this statement is correct, because clustered index means simply that, okay, that your order will be same. Of course, that information is not given, but yeah, maybe, okay, yeah, that information actually most of the time when they ask question from the index point of view, they don't give that information. Yuvraj, see, from the index point of view, when they ask the question from the index point of view, then basically most of the time they only give this information. Okay, so this statement is true, because in the clustered index, the order of the index, the order of search key in the index that is same as the order of search key in the data file. Okay, so this type of index we call clustered index. Is this clear? So most of the time I have seen this in many standard books. I have seen this even in Navate, in all the standard books. Okay, so most of the time from the index point of view, they don't mention that information. But anyway, this is fine. Okay, now let's see this question. Tell me the answer for this, true or false. It is possible. Actually, let me tell you, some of you might be thinking, sir, why this is happening? Let me tell you, actually, when you study the Navate book, or most of the books, either you study Navate or many other books, Navate or like Raghurama Krishna. So if you study these books, then you will find that the primary index is different. The primary index and clustering index, they are different. Okay, so the clustering index and primary index, they are different. In this, primary index simply means that ordering key field. Okay, ordering key field. And clustering index means ordering non-key field. But if you study the Korth book, okay, then in the Korth book, you will find that these two, they are same. Okay, in the Korth book, they will write like this, that primary index is also called clustering index. Are you getting my point? Are you getting my point? So in this book, they will write that primary index is also called clustering index. So that is the reason sometimes this happens. Are you getting my point? See, in the GATE exam, already there is a question. You can notice already there is a GATE question where the clustering index, what is this clustering index? The clustering index is non-key ordering. So this type of question you can notice. Okay, so you can notice again, this is based on the Navate convention, and the Navate convention is used in the NPTEL also. If you watch the NPTEL lectures, then there also this Navate convention is used. So that is the reason we will follow this. Is it clear? Okay, so actually some because of this ambiguity, sometimes you have to feel the intention of the question maker. Is this clear? So you can check it out. Today you can check it out. What to do? You check it out. Navate, you check it out. In the Navate, primary and clustering. In the primary index, you will find OKF, and in the clustering, you will find O and KF. Okay. And what to do? In the Korth, you check it out. They will write that primary or clustering. Means according to them, they are basically same. According to them. Is this clear to everyone? So sometimes you have to basically get the sense. Okay, yeah, you have to basically feel the question maker's feeling. Who is the question maker? Okay, depending on that. But I don't think that you will find this ambiguity in the GATE questions. See, all the GATE questions, if you see, all the 3 GATE questions, if you see, you can solve them without ambiguity. Because in one question, primary is not even given. Only clustering index is given. Are you getting my point? Are you getting my point? See, just think about it. Think about it. If one question comes in which primary index is also given in the option and clustering index is also given in the option, then you can challenge. You can challenge the question. You will get the marks. Remember, whether you follow Korth or whether you follow Navate, you will definitely get the marks. So don't worry about these, I can say these ambiguous things. Never worry about them, because you can challenge the question and you can give the screenshot of the Navate and you will get the marks. Or you can give the screenshot of Korth, you will get the marks. Are you getting my point? Or you can give the screenshot of NPTEL lectures. You can give the link of NPTEL lectures, you will get the marks. This has happened many times in the previous GATE exam. For the last 6 years, I have seen this. Many times the answer will be something like answer will be option A. Then people will challenge and the answer will become A, C. Okay. So for 2 options, they will give you answer. Are you getting my point? But never leave the question. Whenever you have this type of ambiguity and you are confirmed, you are sure that option A, option B, both are correct. And let's assume question is MCQ. Let me assume question is MCQ and you are sure, you can guarantee that option A, option B, both are same. Both are correct. Then at least one of them you tick. Because in the GATE exam, what they will do? They will give marks for A, B. They will not give marks to all. Are you getting my point? So this type of ambiguity, whenever it happens, then you will never lose marks. This I can tell you. So don't worry about it. So we will follow Navate. Is this clear to you? Is this clear? Tell me. We will follow Navate because that is followed in the NPTEL lectures. The NPTEL lectures, I have given you a screenshot also. Yes or no? Did you notice when we were learning secondary index, primary index, clustering index, NPTEL lecture screenshot I gave you, IIT Madras. Yes or no? Agree or not? So that is the reason I gave you those screenshot. There was a reason, because I knew this time will come. Okay. This situation will come in the future. This situation will come. So that is the reason I gave you a screenshot of Korth. Sorry, I gave you a screenshot of Navate. I also gave you a screenshot of this NPTEL series. Okay. NPTEL playlist. So you have enough information. Now you have enough knowledge, enough information. Whatever we have seen, that you follow. Just stick to that. Is this clear? But in your mind, you keep this in your mind, that sometimes you have to get the feeling of the examiner's mind. Are you getting my point? You have to feel what the examiner might be thinking. Okay. So that is the reason these small ambiguities are happening. Now, for the last like 2-3 questions, you are feeling right. For the last 2-3 questions, you are feeling some ambiguity. Yes or no? You are feeling some ambiguity is there, sir. I know. Okay. And that ambiguity happens because of this, Navate versus Korth. These are the standard books most of the people follow. Let me tell you. Navate and Korth. These are the most followed standard books of DBMS. Okay. Like in every subject, there is a standard book which is most followed. Like in algorithm, Corman is followed. Okay. So like that. So in every subject, some standard books are most followed. Similarly, in the DBMS, Korth and Navate, these are the most followed books. So we are using Navate. The reason is simple, because NPTEL also helps us. Yes or no? NPTEL is also in our support Navate, so that we have two support. We have support of NPTEL and we have support of Navate. So just follow whatever we have seen, just follow that. Okay. And this little bit of ambiguity, okay, I told you what is the reason. Is this clear? What is the reason of this little bit ambiguity? That reason I told you. But because of this ambiguity, you will never lose marks. That I told you. So don't waste your time. Many times I have told you in many different subjects. Yes or no? In many different subjects, this I told you many times, that never waste your time whenever you have this type of author ambiguity. Whenever something is author dependent, you never waste your time. And you can check it out. In last three gate questions, you can solve them according to any book. Yes or no? In those last three gate questions, there was no ambiguity. You can solve them according to any author, you can solve them. So that is the benefit of gate exam. In the gate exam, everything is very, I can say, very clear. In the test series, of course, there will be something like, if the test series maker has only studied Navate, let's assume the test series maker, if the test series maker has only studied the Korth book, then he will create the question from the Korth book. He does not have the knowledge of Navate, because most of the test series makers, most of the people who create test series for these coaching institutes, okay, they are students. You can't expect that a student will study 4 or 5 standard books. Yes or no? You can't expect that. So the test series makers are students who are preparing for the GATE exam. They create the test series. And when you are solving those questions, then those questions are very much author dependent. It happens. But don't worry, in the goclass test series, the questions are created by me, Arjun sir, and Sachin. Arjun sir is PhD in computer science. Also MTech from ISC Bangalore. Me and Sachin, we are MTech from ISC Bangalore. So, okay, so these books, all these things we have studied, many different books, 5 or 7 books we have studied. So we know that where is the author dependent concepts. Okay. So that is the benefit of goclass test series. You will not find these, I can say, stupid questions. Okay. Anyway, so is this question clear to everyone? Now let's move on. So far, is everything clear? Please tell me. Let's take one moment. So far, is everything clear? Okay. Now let's move on. Let's see this question. True or false? Tell me. It is possible to create several clustered indexes on a given data file. And the answer is no, false. This statement is a false. What about this? It is possible to create several unclustered index. Yeah, this statement is true. You can create unclustered, simply means secondary. So you can create many unclustered index, means secondary indexes. So many secondary indexes you can create. That is fine. But you cannot create many clustered indexes. At most one clustered index you can create. What about this question? An index can only be created on unique field, means on candidate key. And the answer is, of course, false. And this statement is because you can create index on any field, right? In your relation, if you have 10 fields, then you can create index on each of them, each of those 10 fields. Okay, so index can be created on any field. Whatever field you take, you can create index on that. Tell me the answer for this question. What is the record ID? Means record address. Do you understand? I told you what is record address. So this record address we already know. What is the record address? You can order the record ID or record address. This is simply your block ID, means block address, plus the offset. Offset within the block. Position within the block. Position of record within the block. Within the block, what is the position? Right? So you can easily see that record address or record ID, both are same. So this record address is basically nothing but what is your block address. First you go to the block and then this offset within the block. Okay, so first you go to the block. This is your block. In that block, this is your record and this is called offset. Okay, so this is your record ID. Now you tell me about this question. Given a record ID, how many IO needed to fetch into main memory? If I give you record address, remember I have given you record address. I have given you record address. I have given you record address. Do you need to fetch the block anyway? Tell me. I have given you record address. Do you need to fetch you need to fetch block? Array, you have record address. So can you directly fetch the record without fetching the block? Can you directly fetch the record? No, we cannot do that, right? Because block is the smallest transfer unit between disk and main memory. The unit of access is block. So even if I give you record address, even if I give you record ID, then also you need one IO. But because the address is given, right? Yes or no? Because the record address is given, so one disk block access you need. One disk block access you need. Because what you can do, basically from the record address, you can take it out. Actually, this record address is like this. This is your record ID. So this part you can use. Are you getting my point? This is your record ID. In the record ID, this is the block ID. This is the block address. And this is the offset. And this is the offset. Okay, so what you can do, you can use this block ID. From the record ID, you can take this block ID and you can access. Okay, so you have this block address. Once you have this block address, so you only need one disk block access. Is this clear to everyone? Please tell me. Have you seen this type of situation in the paging, in the operating system? In the paging also we have seen this. Yes or no? That address is a address contains multiple fields. Your address is created by multiple fields, like CHS address, cylinder, surface, and your sector, that address. So this type of situation, the same situation happens here. Your record ID means block ID plus offset. So from the record ID, what you can take? You can take the block ID. This block ID you can take. And once you have the block address, once I give you the block address, tell me how many disk block access you need. Once I give you the block address, you have the block address, then you only need one disk block access. You can, okay, how much time? Seek time plus rotational time plus transfer time. Yes or no? But anyway, I can say one disk block access we need. So one IO we need once you have the record address. You can read it. Whatever I told you that is written here, you can read it. Okay. Now let's see. Let's see this. Consider a heap file. Okay, can we create clustering index on heap file? On the heap file, can we create clustering index? The answer is no. Because if you want clustering index, then your file must be physically ordered by non-key attribute. That we have already seen. Tell me the question number 28. How many clustering index can we create on a file? The answer is at most one. That we have already seen. Question number 29. Can we create primary as well as clustering index together? Is it possible? Is it possible that we can create both of them together? The answer is no. At most one of them we can create. We cannot create both of them. At most one of them we can create. This we have already seen actually. Okay. At most one of them we can create. No. Gate ke according yes hoga na. No. Gate. See, this is actually, this statement is taken from the Navate. In the Navate, this statement is given. Just follow our lectures, Nikhil. Okay, just follow whatever we have seen, just follow that. Is that clear? Just follow that. I told you what is the ambiguity, all these things I told you, but follow this. Follow whatever we have seen, because NPTEL follows that. And in the GATE exam, the questions will be created by NPTEL professors. They will create the questions. Okay, so whatever we have seen, just follow that. Okay, so can we create both primary as well as clustering index on the same file? The answer is no, we cannot create, because you can easily see that once you order the key, once you order a key attribute, then every other attribute will become unordered. And once you order a non-key attribute, then every other attribute will become unordered. So at most one of them you can create. Can I say at least one of them you can create? Tell me, can I say, can we create at least one of them? Can we create primary or clustering index? Can I say that we can create primary or clustering index? We can definitely do. The answer again is no. At most one of them you can create. Remember, at most one of them you can create, because if your file is organized, if your file is heap file, if your file is unordered, then you cannot create primary index, you cannot create clustering index. Okay. Now let's see some questions, some beautiful questions we are going to see. Some thought-provoking questions. So far, all the questions that we have done, these are quite easy questions. Okay. Now we will see some questions where you need to think. Okay. Now let's see some thought-provoking questions. You see this question. Okay. What do you think? What is the answer? Processing a range query. For example, salary between 10,000 and 20,000. I want salary between 10,000, 20,000. Okay. Processing a range query using a clustered index is always faster than unclustered index. Tell me, is always faster than unclustered index. Tell me, is this true? What the question is saying? The question is saying that basically on salary, if I have clustered index, on salary, if I have unclustered index, in which case this range I can find more easily. Tell me, in which case we can find more efficiently? In the case of clustered. But you think about, see, the answer is true. I agree. The answer is true, but a little bit thought we need. The answer is true, but remember, we need to think a little bit. See, okay, on one side, I am creating clustered index on, let's assume on one side, I'm creating clustered index on salary. On another side, I'm creating clustered this secondary index on salary. Let's assume salary is the key. Okay, let me assume, like, it does not matter, but let me assume salary is the key or non-key or whatever. It does not matter. Okay, you can take primary index. So, okay, yeah, of course, actually salary is not a key, of course, because many people, they can have different salary. So anyway, that doesn't matter. So you can notice you have a clustered index on salary and second index on salary. Now you tell me, in which situation finding these records 10,000 to 20,000, why this becomes very easy? Anyone tell me? Anyone tell me? Okay, I want to find 10,000 to 20,000. Those salary I want to find. In this situation, why this is becoming easy? Tell me. Can anyone tell me why this is becoming easy? When you have clustered index on salary, why this range query is becoming easy? Why this range query? Why this range query? We want to find those records. We want to find records. We want to data records. We want to find data records with salary 10,000 to 20,000. Okay, between this range. So what is the reason? What is the reason that if you have clustered index on salary, this will become very easy? And the answer is very simple. Because if you are creating clustered index on salary, what this means? Tell me. If you are creating clustered index on salary, this is your index. This is your index. Okay, this is your index. In this index, you have two fields. One is salary, another is block pointer. Okay, these are the two fields. But what happens to the data file? Tell me about the data file. Yes, very good, very good. So if you are creating clustered index on salary, it automatically means that this salary is ordered here, right? It automatically means that this salary is ordered here. That is the benefit you will get. Okay, that is the benefit you are getting. Remember, this is the reason, because your salary is ordered. So I can say this range, where this range will be. So this range will be where? I can guarantee that this range will be in the consecutive blocks. Very good, very good, very good. So this range will be in the consecutive blocks. Yes or no? I can guarantee this because salary is ordered. So this range also will be in this block. Like, okay, there will be 10,000 salary and here you have 20,000 salary. So this will be in the consecutive blocks. Correct? Agree or not? So these are in the consecutive blocks. These will be in the consecutive blocks. This we already know. Because if you have a clustering index, then automatically means that this salary is ordered field in the data file. In the data file, this salary is ordered. So automatically what it means, this range query, this is a range query, and this range query will have consecutive blocks. These will be the consecutive blocks. So it becomes very easy. What you will do? Okay, you can very easily find the 10K. Your focus will be where? Tell me. On the 10K or 20K? You will find on 10K, right? You will just follow this. Okay. So what you do? You follow this and you go here. And then you can just access them consecutively, because you already know that it is your salary field that is sorted. You already know your salary field is sorted. So what you can do? You only have to take this. You have to go to this block, whatever is this block, you have to go to this block and then you have to access. Okay. So this is very easy, right? In this situation, what is happening? In the other situation, what is happening? Mavit is saying, how would we know the end? You can write some program. Mavit, algorithm, SQL, okay, you can do something. This is the logical, like logically, of course, we can do all these things. These are not hard. Tell me, finding the end, is that too hard? You can do some coding while this, where you can do some, like where salary is less than 20K, okay, greater than 10K. So some coding you can do. There's no problem. Okay, whatever is your logic, you can implement that logic. Implementation of logic is not a hard thing for computer science people. They can implement it. Okay, so you think about the logic that will be implemented. Some coding will be done, something will be done. Okay, that will be implemented. Okay, now let's see this secondary index on salary. Now tell me, secondary index on salary, does it tell you anything? Does it tell you anything? Where is 10,000? Where is 20,000? Where is 15,000? Does it tell you anything? So you can notice here also you have salary and block pointer or record pointer, whatever. Even if you have record pointer, then also there is no benefit. Even if you have record pointer, let me assume you have record pointer, right? Yes or no? So let me assume you have record pointer. Now also there is no benefit, because this you can, what you have to do now, tell me. Now if you want all the records, then what you have to do? This is your data file. This is the field salary. Now you tell me what you have to do. Anyone? Yes, very good. Yuvraj, very good. Fetch each time. Now what you will do? Now in this index, you will search where is it 10K. Okay, so in this index, first you will search where is 10K. In this index, you will take this 10K. You will go to this. And you will access. Then you will take this. Maybe you will take this 11K. You will take this 11K. And this 11K, you will take this and you will go and you will search. Okay. Then you have this 12K. And this 12K can be anywhere. For example, this 12K can be here. Yes or no? Isn't it? Okay. So are you getting my point? So you cannot say any location, like you have 13K. So this 13K you take, and maybe this 13K, maybe this record you will find here. Are you getting my point? Tell me, is this clear? So, okay. So for every, like I can say 10K, 11K, 12K, 13K, till 20K, for everything you have to do this. So which is faster? Clustering index on salary or secondary index on salary? Which is faster for range queries? For this type of range queries, we want a range. This type of range queries when you have. So for these range queries, this is definitely faster. Okay. So you know that answer is true, but this logic gives you more intuition. Yes or no? You know the answer is true. Okay. But okay, now this logic, did you understand this? Tell me. So if you create clustering index on salary, that is definitely For the range queries, whenever you have range queries, then that is beneficial. And the reason, if anyone asks you what is the reason, then what you will say? You will say the reason is this, because the range queries, remember, this I'm talking about the range queries, because the range queries will be in the consecutive blocks. Agree or not? This is the reason, because the range query will be in the consecutive blocks if you create clustering index on salary. So this is the reason. Okay, so let me write the reason here. So you can notice, if you create clustering index on salary, then this range query, range query records, okay, they are found where? Tell me, they are found where? They are found in consecutive, blocks. You can guarantee that they will be found in consecutive blocks. So if you have created, remember again, if you have created this type of index, then you can take the benefit of this. Yes or no? If you have created this index, if you have created this clustering index on salary, then you can take the benefit of this. The benefit of this fact you can take, that the range query records will be found in the consecutive blocks. Okay, so that benefit you can do. Yes, benefit kar sakte hain. Okay, so you can take the benefit of this fact. Okay, very good. Now let's see another question. And this is the question that I want to take. Is index always helpful? You tell me. Is index always helpful? Is index villain or hero? Like index villain or hero, So if I create YouTube thumbnail, nowadays in all the coaching institutes, they create many. In the Go classes, we have never done this so far. See, if you see the Go classes thumbnail, they will have the information like, okay, this is the topic. A boring thumbnail is there. You will find, yes or no? Whenever you will see Go classes thumbnail, some boring thumbnail, you will find that. Yeah. So in the Go classes thumbnail, we are never like surprised. Yes or no? Like this type of thumbnail you will find on the internet. Oh, like, okay, face here and mouth is open. Okay, so like I don't like I don't know what they are doing, but they are getting many views. Okay, whatever they are doing, they will get many views. There is a particular channel, you can just check it. Okay, like I don't know whether like so you can check it, their thumbnail, you check. Okay, there's a particular they have millions of views or lakhs of views they have on almost all the videos. Very poor teaching they do, very poor teaching. Okay, almost lakhs of the students in this world, okay, more than 2-3 lakhs of the students, they watch the videos. Those videos people are watching, people are learning wrong concepts. Okay, but anyway, like what we can do. So what I'm saying, that in all the thumbnails you will find this type of, like, there are some channels, Mavit, you already know. Okay, I will not mention it, but you will find some channels where, like, you in very of these like many views you will find, many comments you will find. Okay, students will be calling them god, sir, you are god. Okay, but those people are teaching wrong concepts. They are teaching. Okay, forget about proof. Okay, they will not teach you proof, they will not give you quality, they will only teach you in a very easy manner. Everything they will teach in a very, very, very easy manner. They will even, I can say, everything that is worth it in any concept. What is the most crucial thing? Okay, what is the, I can say, what is the part that you should understand? That part they will leave out. Okay, they will throw it, and I can say just the easy portion they will teach. And what will happen? Most of the students, okay, they will think, I understood, because I understood, so he is a god, because I understood, so he is the best. Okay, the student does not know that you only understood what they have taught you. You did not understand the concept. What they taught you, those statements you understood, or maybe you did not understand those statements, you have by hearted. You really did not understand. He's not even I can say, he's not even making you understand the concept. He's making you by heart the concept. Just wrote learn this, just wrote learn that. Okay, so anyway, this happens, and there are millions of views. You can check it out. You can check it out. Okay, there millions of people, they are watching those videos, and this is really unfortunate thing in the like so anyway, so this is what I'm saying, that if we create in the Go classes, if we create one thumbnail for this, then it will be like index hero or villain. Yes or no? Okay, maybe we will create. We will also check whether we get a subscriber or whether we get the views or not. Because okay, so okay, maybe we will check this experimentation. We will do simulation, right? Simulate. I told you, like which strategy is going to work. We don't know. Okay, so we will also try. Anyway, so let's come to this. So is this index always helpful? Tell me, anyone. Is index always helpful? Anyone? Let me give you this question. Tell me this question number 31. Read this question and tell me. No, in terms of time, is it always helpful? Mavit, is index always helpful in term of time? Will index always save you time? Will index always save you time? In terms of time, I am asking. Okay, let's see. Interesting things are coming. Let's see this question. True or false? Read the question carefully and tell me the answer. Don't worry if you get the wrong answer. Don't worry. Consider a relation stored randomly. Stored randomly means what? Stored randomly means what? That is a heap organization. So in a random order, we have stored it. Okay. In a random order, we have stored it. So it means this is a heap organization for which only index is unclustered. Means second index is there on the field called salary. Okay. On the salary, on this attribute, you have index. That is the second index. If you want to retrieve all records with salary greater than 20, all these records, if you want to retrieve, using the index will be best alternative, or you should directly do. Think about it and tell me. Please think about it. Okay, think about the scenario where almost everyone has salary more than 20,000. Think about this scenario where almost everyone has salary more than 20,000. Please tell me. In terms of time, don't think in terms of space. You think in terms of time. Tell me, using index, how much time you will take, and without index, how much time you will take. Think about it. Give some thoughts. I'm also like, okay, I'm giving you time. You can think about it. Let's think about it. So your file is completely unordered. Okay. Your file is using the heap organization, and you have index on the salary, and you want to search the records where salary is greater than 20. Will using the index, will it save you time? Using the index, is that going to save you time? Okay, now let's see. The answer is no. The answer is no. Let me take this. See this. See this. So you have this query. I want age greater than 30. Okay. I want age greater than 30. Let's assume. Now you can notice, consider this situation where most of the people have age greater than 30. Then what will happen? See, there is an employee table. In that employee table, this is a data file, right? So this is your data file, correct? This is your data file. And this is unsorted, means this is using the heap organization. Let me assume like randomly you have put it, or I can say unsorted on salary. On this field, it is unsorted. We only care about this field. Agree or not? Are yes or no? Let's assume this is unsorted on salary. Let's assume this is unordered on salary. On the salary field, this is unordered. Now, sorry, on the age. Okay, in this question, we are taking age. So on the age field, this is unsorted. This is the employee age. We want those. So there can be many blocks, right? There can be many blocks, thousands of them. Okay, yes, correct. So maybe there are many blocks. There are many blocks are there, many blocks. And let's assume that most of the employees, they have age greater than 30. Now, in this situation, if you directly do, tell me, in this situation, if there is no index, let's assume you don't go via index. If there is no index, then on average, assume that almost all the records have, I can say, age greater than 30. This is our desire. We want what we want. Our objective is records with age greater than 30. And just for a moment, you assume that almost all the people have, almost all of them, almost I can say 90% of them, let's assume they have age greater than 30. So if you have no index, then what is your access cost? Then almost all the blocks you have to access, right? Yes or no? Are yes or no? You have to access all the blocks because unordered by age. This file is unordered by age. So the access access cost, I can say that is number of blocks. Can I say number of blocks in file? Agree? So this will be your access cost because there is no index. So you have to scan the file, right? Because there is no index. So you have to scan file. File scan you have to do. What you have to do? You have to scan the file. This is clear, right? Okay. Correct. Okay. Now let's see the next point. Remember, we want all the people whose age is greater than 30. Okay. So this is what we want. So access cost will be number of blocks. How many blocks are there? Now you take this. Now let's assume you have created secondary index on salary. Okay. And of course, once you create the index on salary, then you have to go by index, right? Yes or no? That is the point. Once you have created the DBMS is your software, your program does not have the mind. Okay. Your program does not have, basically whatever you write, whatever programming you will do, that it will follow. So if you have created this index, second index, if you go by second index, then will it benefit you? Will it benefit you? Let's assume you have a record pointer. Let me assume you have a record pointer. Okay. Or maybe block pointer. That does not matter. But will it benefit you? You want where salary, you want where age is greater than 30. You want that. You want age where age is greater than 30. So you have second index on age. Now what will happen? Tell me. Tell me what will happen? Array, this will happen. See, this 20 you will skip, right? You don't care about this 20. So this 20 you will skip. But now most of the people have 30. Most of the people have what? 30. Correct? Most of the people, they have 30. Now what is going to happen? First of all, you will access this block. First of all, index block you will have to access. So one access is already done. Yes or no? One access is already gone. You have to access the index block you have to access. So this is a block access. One block access you have already done. Then maybe this you will find in this. Okay. Then you have to access this. You have to access this. Then maybe you will find this here. Then again you have to access this. Then maybe you will find this here. Then you have to access this. Almost all people, if they have age more than 80, more than 30, then what will happen? So how many block access you need in this situation? So you can search, I want, remember your objective. I want age greater than 30. This is what I want. You can assume I can say that almost everyone has this age. Greater than 30. Now in this situation, what is going to happen? In this situation, with the index, if you create with index, how much cost? You have to access the file blocks, number of file blocks plus number of index blocks. Yes or no? Agree or not? So you will access file blocks also, index blocks also. So it is, I can say, it is helpful or not? Tell me. So remember, index is not always helpful. It is not the situation that index is always helpful. And what if only 10% are older than 30? Now you might be thinking, sir, you are taking a special case. Correct? You might be thinking, sir, you are taking a special case. You are taking where most employees are older than 30. But if very few people are older than 30, now what will happen? Tell me. If very few people are older than 30, then what will happen? In that situation also the same thing actually will happen, because if your, I can say, if your I can say only 10% people are older than 30, then in this situation, so in this situation what will happen? In this situation also actually a lot of access you will have to do. Okay, but yeah, I think in this situation it will be helpful. Okay, it will not be very bad, it will be definitely helpful. Okay, it maybe it will, like, okay, we cannot exactly say, it might be helpful, but you can notice if they are distributed, only 10% people are older than 30, But if they are distributed in all the blocks, like in every block, if you have one person with age greater than 30, then what will happen? Are you getting my point? Are you getting my point? What I'm saying? See, let's assume that this scenario you assume. Okay, because your file is completely unordered, right? This is your data file. This is your data file. And this data file is unordered by age. This data file is unordered by age. So this is completely unordered. So it is possible. It is possible, right? It is possible that in every block, in most of the blocks, you have, I can say, age one record of age greater than 30, right? Okay. So it is definitely possible. Okay, assume that most of the blocks, this can happen, yes or no? This can happen that most of the blocks can have some record with age greater than 30. At least one record. At least one record is fine. Yes or no? At least one record is fine. At least one record is fine. So it can be, it is possible that overall less number of people you have more than age more than 30. Overall you have less number of people, but because it is unordered by age, so what can happen? It can happen that most of the blocks, they have some record, at least one record with age greater than 30. Now in this situation, you can again notice in this situation, your with SI, with this secondary index, okay, more cost. Agree or not? This is more costly. And in this situation, the file scan is better. In this situation, the file scan can give you better performance. The better performance can be given by file scan, but this with second index, it will give you bad performance. Tell me, did you understand? See, even if, like I can say, even if few people with age greater than 30, even if you have few people only, then also because of these two reasons, okay, so then also you can see that this and this can happen. Okay, is this clear to everyone? In this case, you can notice, in this case, SI is costly. Again, this SI will be costly. Why this SI will be costly? Because almost every block has some record with age greater than 30. So with SI also, you will see in this second index, again, you have to access the index. Also, you have to access all the blocks of the file. The access cost will be all the blocks of the file plus all the blocks of the index. Are you getting my point? Or I can say all the blocks of the file plus some of the blocks of the index. So this second index, with the second index, this is become more costly, and file scan in this situation is better. Mavit, any other doubt? Is your doubt clear? Please tell me. Please tell me, is your doubt clear? Anyone has any doubt in this? These two scenario, did you understand? Let me know. Two scenario are there. These two scenario, did you understand? If almost everyone is greater than, if almost everyone has age greater than 30, or few people have age greater than 30, but because it is unordered, so most of the blocks, they can have some record with age greater than 30. So in this situation, with SI, with second index, you will take more time and your file scan will be better. Okay, so this is the point that I want to say. Is index always helpful? And the answer is no. Is this clear? So you can now you can answer this question. Now tell me the answer for this question. You want to retrieve all the records where salary is greater than 20, and you have an index on salary, you have a secondary index on salary, and you want to retrieve where salary is greater than 20, but your file is not sorted by salary. Yes or no? Agree or not? Your file is not sorted by salary. Because your file is not sorted by salary and you want salary greater than 20, it is possible that file scan can be better than the index. Yes or no? It is possible that the file scan can be better than the index. I hope this point is clear. So this statement is a false. Tell me, these two scenarios, are they clear? Anyone has any doubt? You can also read this. The same thing is written here. You can, this question is a standard question, let me tell you. This standard question as it is, I have taken. This is from a standard university. This is a very nice question which I have taken. Please tell me, did you understand? So is secondary index always helpful? That is not true when you want to search for a range. See, okay, this is the conclusion. What is the conclusion? The conclusion is this. Secondary index is helpful when secondary index is very useful. When it will happen? When you want a record which only exists in one block, or I can say yes or no, agree or not. So secondary index is useful when we want a particular record, when we want a particular record, not records, when you want a particular record which when you want a particular record which, okay, I can say which can exist in very few number of blocks, very few number of blocks. Do you agree? Please tell me, do you agree? If your record or value, if your value or record exists in very few number of data, if in very few number of data blocks, then your second index will be fine. Yes or no? For example, if I want all the people with age equal to 30, like example, okay, people with age equal to 30, there it is very good. Yes or no? Agree or not? Okay, there your second index is very good. So here your second index on age is very good, will help you very much. Is this clear? Please tell me, are you getting my point? So this second index is useful. When this is useful, this is useful when you don't have to access a lot of data blocks. Okay, so this second index is useful when we don't have to access too many data blocks, when we don't have to access too many data blocks. Can I say this? When we don't have to access too many data blocks. So if you don't have to access too many data blocks, then definitely this second index is useful. And when this second index is, I can say burden, when the second index is burden, when this will be burden, when you have to access too many data blocks, when we have to access too many data blocks, example is this type of queries. Example is range queries. Okay, I can say example is some I can say some range queries. Range queries are the example. For example, if you want age greater than 50 and less than something. Okay, if you want, for example, if you want age where age is greater than 30 and less than 50, here also your second index is not helpful. Why? Anyone tell me, anyone? Why? Because it automatically means that your data is not sorted, right? Yes or no? It automatically means you have a secondary index on age. You have secondary index on age. You have secondary index on age. What it tells you? It tells you that in the data file, age unsorted. It tells you that in data file, age unsorted. Age unsorted. In the data file, age is unsorted, right? Is this clear? Okay, let's wait for 1 minute and tell me, do you have any doubt? Or are you understanding this question? This point? This is a very nice question from the standard university. I told you this. I want to explain this question. I want to explain. So I am giving you the final conclusion. This final conclusion I am giving you. So, okay, is this clear? That secondary index, when this will be helpful, when this will be useful, this will be very much useful when your point queries. See, this type of queries are called point queries. Yes or no? Okay. This type of queries are called point queries. Are you getting my point? These are called points. Some people, they call it point queries. You are pointing to particular record or pointing to maybe 1 or 2 record or 3 record. Are you getting my? Okay, tell me, is this clear? So this type of queries, they are called point queries. You are pointing to a particular record. You want a particular record, or your record exists in few blocks. Okay, exist in I can say very few number of blocks. Exist in very few number of blocks. So this is the idea. Okay, and if you have range query, then it is not useful. Your second index, that is a burden when you have a range query, because the reason is very simple. If you have second index on age, then it means in the data file age is unsorted. So it is possible, right? Tell me, is it possible that every block has at least one record of this? Is it possible? Is it possible that every block has at least one record of this? Yeah, that is possible, right? So in this situation, second index may be burden, or I can say not useless. So in this situation, I can say your second index is not useful. Okay, so this is the conclusion. Range query versus point query. Did you understand? Range query versus point query. Two type of query. In one type of query, we want a particular record. In another type of query, we want a set of records. So this is the range query and this is the point query. So this SI, this secondary index, this is useful when you don't have to access too many blocks. If you are not accessing too many blocks, then it is useful. But if you are accessing too many blocks, too many data blocks, if you are accessing, then it is not useful, this second index. The last question number 32. Now tell me, processing a range query using unclustered index, processing a range query, processing a range query, I am talking about range query using unclustered index, is always faster than file scan, and the answer is false. So some nice questions we have done. 32 questions we have seen. More questions you will find in the Go classes test series. Okay, so from these 32 questions, you got the idea, right? Some idea you got that can anyone solve these questions with vague understanding? With a vague understanding, what do you think? From these 32 questions, how many questions a student can solve? I think maybe 22, 20, 30. Maybe, sorry, 22, 23. Because some questions were very easy. Okay. So if you are solving maybe 20, or I can say 23, okay, if you are solving in that range, then it means that you are very close to understanding the concept, but you don't have a clear understanding. You are close, like, okay, maybe you are close. Maybe if you from these 32 questions, if you have done 20 questions, then you are very good in you are in a very good position. But you need clear understanding. That crystal clear understanding is not there. Because if you have that crystal clear understanding, then definitely you can solve, maybe I can say 27, 28. At least these many questions you can solve. And if you have done almost 30 or 31 out of these 32 questions, if you've done 30 or 31, then most probably you are Go classes student. Most probably. Okay. So more questions of this template you will find in the Go classes test series. Okay. So I think these are enough, and I don't have to give you more questions, because if I solve all the questions, then what you will do, right? Yes or no? So there are more questions, and these questions you will find in the mock test, in the Go classes test series. There you will find. Okay. Now, so again, see, this video we will put on the Go classes YouTube channel, and if you are watching this video, then tell me in the comments, did you get crystal clear understanding about all type of indexes? See, in the last, we have done 2-3 very nice questions at the end. 2-3 very nice questions, some thought-provoking question we have done, right? Yes or no? The last 2-3 questions, did you see? Those were, you have to apply your thoughts, like what is happening here. Okay. So, okay, tell me in the comments. Please make a comment. Okay, because as I told you, the poor material, all the many teachers, they teach very wrong concepts and they are getting many views. So the poor quality material is getting many views, many comments. Okay, so people are watching it. So you can help us, spreading the quality content. So whenever you see a Go classes video, whenever you watch a video and you think this is a very nice video, okay, so it is a quality content, then like and comment. And if anyone asks you, where should they I can say, where should they watch a particular subject, where should they prepare for the GATE exam, okay, then you can suggest Go classes. So please do that, because as I told you, okay, as I told you, you can see on the internet, you can see all the poor material, a lot of poor material is taking millions of views. Okay, a lot of views they are getting, a lot of comments they are getting. But go classes, okay, we are not getting that many comments. Maybe because with proof, when you teach in a quality manner, when you teach, then there is a majority of students, they don't get it, they don't understand it. Okay, of course they can understand, remember, it's not like they can never understand. They can understand, but they should have that confidence, they should have that I can say, they should have that desire that I want to understand the concepts in a best way. Are you getting my point? See, some students, they have made misconceptions about themselves that I can't do it. Okay, proof is not for me. I have seen this. I get these comments. I get this type of comments many times. Sir, I don't want proof. And when I was taking this, uh, feedback for the discrete mathematics, when I was taking the feedback, in that feedback, there was a question. Do you remember? There was a question in that feedback form that do you like proof? Like, do you want the content with proof or without proof? There were some students, okay, there were some students who wanted content without proof. They don't want any proof. And there are many students, you will find there are many students, they don't want proof. They just give us easy. Whatever you explain, just explain in easy terms. I don't want proof, I don't want clear understanding, just give me. Okay, give me something that I can by heart and solve 5 gate questions. Those 5 gate questions will make me very happy. The 10 gate questions that I cannot solve, I will call them out of the syllabus. Okay, so those students are very, I can say, you optimistic, right? So in the decidability, you can see this happens in the decidability. In the decidability, they are able to, from the table, by hearting the table, they are able to solve some questions and they are happy with those questions. The remaining questions where you can where reduction is there, where some something else is there, where you have to apply the proof, where you have to apply the correct logic, where the rote learning will not help you, those questions they will skip. And they will tell themselves that okay, these questions rarely come. Are you getting my point? So okay, don't fool yourself. As a student, every student has the ability to understand everything. If you are learning, at least learn something with proof, at least learn with clear understanding. Why are you by hearting? If you by heart for 1 year, 2 year, there are many students who study for 5 years. Let me tell you, I have seen some students who have studied for 5 or 6 years. They prepare for the GATE exam. Still, they are not able to crack the GATE exam. The reason is very simple, that for the 5 or 6 years, they did not realize that the content they are learning is rote learning. The content they think they are understanding, but they are not understanding. In the GATE exam, they are not able to solve the creative questions. The analytical questions they are not able to solve. They are able to solve only those questions which they have by hearted, which the teacher has made them by hearted. Okay, so don't fool yourself. Everyone has the ability to understand the concepts. Everyone, like those students who are understanding the concepts, those people who top the GATE exam, they are not coming from some other planet. Okay, they are just learning in a quality manner. They are learning with proof. They are understanding the concept. They are not by hearting the concepts. They have the clear understanding of all the concepts. Okay, so anyway, so put your comments, tell me in the comments. Okay,